This is lesson number 2. In lesson number 2, we'll look at multiplication and also introduce the concept of division. As usual, I like to ask the question, what is? What is multiplication? Now, hopefully, you know how to multiply. That's the assumption I'm making here, that people who are watching this tape, whether you are an elementary school aged student or an adult or something in between, you know how to multiply. But what is multiplication? And hopefully, in your mind, what multiplication is repeated addition. In fact, I am told, I was not there, that in ancient Egypt, before multiplication was discovered, that every time a problem that we would do by multiplication had to be done by addition, they'd write the answer down and put it on a brick or on a scroll and keep it in a library because it was so much work to do these problems. And in fact, then someone created multiplication. Multiplication is repeated addition. For example, in our first visual, we see that 6 times 8 means 8 plus 8 plus 8 plus 8 plus 8 plus 8. 6 eighths added. And of course, the answer is 48. Once you learn to multiply, you basically forget this and just simply remember your facts. But it's always a good idea to go back to understand what multiplication is. As again, we get to fractions, decimals, even into algebra, understanding what multiplication is can be very helpful. Notice, multiplication is not counting. It's one step above. Addition and subtraction were counting. Multiplication is now something different. It's repeated addition. It is not counting. The rules are different. Another way to conceive of multiplication is by looking at, for example, the next visual, which shows you a physical representation of numbers that multiply to be 12. Here we have 3 rows of 4. That is, 3 times 4 is 12. Notice if you turn your head sideways, you might see 4 rows of 3. 4 times 3 is the same as 3 times 4. That's 12. The next visual gives an alternate approach to multiplication of two numbers, giving an answer of 12. 2 rows of 6, or if you like, 6 columns of 2, so that 2 times 6, or 6 times 2, is 12. And the next visual gives a third way to multiply two numbers to get 12. 1 times 12, or 12 times 1. Now, let's take a look at a somewhat special number. The number is 9. In our first visual, we see that we have 1 times 9, 1 row of 9. We also could look at it as 3 rows of 3. This is very special. Every one of the arrangements so far has been rectangular. That is, with 12, 3 rows of 4, 2 rows of 6. But this is more than a rectangle. This is a square, 3 rows of 3. And in fact, if you turn it sideways, you still have 3 rows of 3. And in fact, 9 is called a square number because one of the ways to multiply it looks like a square. This will become even more important in future lessons. But right now, let's just recognize that these rectangular arrays, these rectangular groupings of physical things, show us what multiplication truly means. Now, a question I always like to ask involves the next visual. We're multiplying 38 times 247. Now, at this point in time, I'm not going to ask you to multiply it. I'm just going to say, look at the 2 and the 3. They are connected. Where, let's see, 2 times 3 is 6. Where does that 6 go? In what place value? So stop the tape and decide where the 6 goes and justify your answer. Well, a lot of people would try to do that by actually multiplying the entire problem. No. We have 2 times 3, or 3 times 2 is 6. But notice that 2 is in the hundreds place. 2 hundreds. The 3 is in the tens place. And I multiply 3 tens times 2 hundreds. I multiply the digit times the digit. 3 times 2 is 6. But I also multiply the place value times the place value. And tens times hundreds is thousands. So the 6 must go in the thousands place. Not because we did it by rote, because we understand when we multiply, and this is true for fractions and decimals, and any time we multiply digit times digit and place value times place value. That is how we multiply. Now, most of you, like I said, I'm assuming know how to multiply, but I'm going to show you a new method, an alternate method of multiplication. Now, if you like your own method, the old-fashioned way, that's fine. But I think this method, called the lattice multiplication method, is really good. And the reason it's good is because it involves no carrying or renaming when you're multiplying. It's excellent if you have no calculator because there's no limit to the size problem you can do. And of course, it's very useful in multiplying multi-digit, as 2, 3, 4-digit numbers. So let's go to the whiteboard and see how to set up this thing called a lattice. And basically, a lattice is just a rectangle that allows us to multiply, and I believe is a much more efficient way of multiplication. Okay? Basically, what we're going to do is we are going to first make a rectangle. And since we're multiplying a 2-digit number by a 3-digit number, we'll divide the rectangle into 3 columns for the 3-digit number and into 2 rows for the 2-digit number. And then we'll connect each of the corners in the smaller rectangles to its opposite. Now, it's very important to go through. In case you don't, you need to make it a little curvy, that's okay. It needn't be straight, but it must go from corner to corner to corner and out the bottom, as we'll see when we actually do this. So that is how we would multiply a 2-digit times a 3-digit. That is the lattice that will allow us to do this. And in the first visual, we see that we're going to multiply the same problem we just started with, 38 times 247. And we put in the numbers, and then the next visual shows us actually drawing the diagonal lines that will help us to do our adding when we finish multiplication. So we're going to multiply 3 times 7. And the wonderful thing about lattice multiplication is there's no order that you must multiply in, because each of the multiplication parts is independent. And if we do 3 times 7, we get 21. And notice, by splitting each box into 2 parts with that diagonal line, we can write the 2 and the 1, 21. We skipped over to 3 times 2. That was the problem we looked at before. Where does that 6 go? Notice there's a 6 there. Notice the left part of that box is blank. If you want to put a 0 in, that's fine. My wife says that every little place should be filled up. So obviously, when your answer is a 1-digit number, you would put a 0 in that tens place box, if you would. The next visual shows the completion of the multiplication. 3 times 4 is 12. 8 times 7 is 56. 8 times 4 is 32. And 8 times 2 is 16. Then we add, and that's where the diagonals come in. We add along the diagonals. They represent the place values. Okay? So basically, in the ones place, we have a 6. In the tens place, we have a 1, a 5, and a 2. Well, 1 plus 5 plus 2 equals 8. In the hundreds place, 2 plus 2 plus 3, that's 7, plus 6 is 13. We write down a 3, and we carry the 1 over to the thousands place. 1 plus 6 plus 1 plus 1 is 9. And we have our answer. And the next visual shows us that indeed 38 times 247 is exactly 9,386. Now, let's do a few more at the whiteboard. In fact, I think what I'd like to do is start off with a simpler problem and have you try to do it, and then come on back and I'll do it and make sure if you got it right or not. This is going to be a 2-digit by 2-digit problem. So we'll go ahead and set up for a 2-digit by 2-digit lattice, connect the corners, and again, it's really important. It's not important that the lines are straight. If your hands are shaky, that's okay. And we're going to do 53 times 72. Now, something I should really do here is an estimation. We talked about that in lesson 1. It's really important to estimate. Now, what is 50 times 70? 50 times 70, 5 times 7 is 35, and 2 zeros. So 50 times 70 would be 3,500. Let's remember that. Our answer should be close to 3,500. At this point in time, if you think you know what you're doing, and hopefully you do, I'd like you to turn the tape off, stop the tape, and work this problem, and work it using the lattice method. Even if you feel comfortable with what I call the old-fashioned method, try this. So stop the tape now, come on back, and we'll work the problem out here. Okay, 7 times 3 is 21. 7 times 5 is 35. 2 times 3 is 6. And again, we could put a 0 in there, but I'll leave it blank. And 2 times 5 is 10. I mentioned something, if you're a parent who's helping your child, this is a great way to see where their problems are if they're having multiplication problems. Because you'll notice that each of the boxes has a multiplication fact. So for example, if I thought that 7 times 5 was 40, and I had put 40 in there and did everything else correctly, you'd see the wrong answer, but you'd also be able to determine what the problem was. In the old-fashioned method, sometimes as a teacher, it's very difficult to understand what error the student made. You gotta try to look inside their brain because it's very difficult. Here, the multiplication facts are there. If all the multiplication facts are correct and the answer is incorrect, that means you added incorrectly. Let's go ahead and add now. We have a 6 here in the ones place. 1 plus 0 is 1. 2 plus 5 is 7 plus 1 is 8. And we only have a 3 in the thousands place, which means that 72 times 53 appears to be 3,816. Now, what was our estimate? Our estimate was 3,500. 3,500, 3,816, relatively close. I believe our answer is correct, and the estimate helps me with that belief. Well, let's do another problem. This one just a little bit more complex, but as you can see, there's no limit to the size of the numbers you can multiply with this method because you don't have to worry about little carry numbers in various places. Everything is very simplified. So let's erase this and put up a 3-digit times a 3-digit problem. So let's go ahead and draw a little bit bigger box and divide it 3 ways that way and 3 ways that way, and draw our diagonals, our lattices. And again, we want to connect all the corners. All right, now we're ready to put the question in. And the problem is 279 times 461. Before we try to multiply it, let's go ahead and estimate. And I would say that that's 300 times 400. And again, you may say that's 200 times 400 or 200 times 500, but I liked 300 times 400. Well, 3 times 4 is 12, and there are 4 zeros, so that'd be what, 12 with 4 zeros, be 120,000. So our estimate will be 120,000. Let's go ahead and multiply now. So go ahead and stop the tape, multiply this out using the lattice method, look at your answer, and come back, and we'll see how I do it. Okay, let's play around some, just to show you that you don't have to do it in any particular order. How about we start with 6 times 7? Well, 6 times 7 is 42. If this bothers you, by the way, and you like starting at the right and going right to left, that's fine. It doesn't make a difference here. 1 times 9, well, that's easy. In fact, the whole ones are easy. 1 times 7 and 1 times 2. Okay, 4 times 9 is 36. 6 times 9 is 54. Let me make that 4 look more like a 4. There you go. 4 times 7 is 28. 4 times 2 is 8. And 6 times 2 is 12. So if my multiplication is correct, which I assume it is, we go ahead and add along the lattices right now. Well, 9. 4 plus 7 is 11. We carry the 1. 6 and 5 is 11. 2 is 13. 2 is 15. And 1 is 16. Carry the 1. 3 plus 8, 11. Plus 4 is 15. And 2 is 17. And 1 is 18. And again, we carry the 1. 2 plus 8 is 10. 1 is 11. 1 more is 12. And of course, Since there's nothing in that place, we'll just put the 1 there. So it looks as if our answer is 128,619. Our estimate was approximately 120,000. I feel very comfortable with this answer because my estimate says that this is a very reasonable answer. So I think we could see that multiplication can be made very simple. If you know your facts, which we assume you do, and you can add, which we assume you do, you can. Lattice multiplication makes this a very reasonable problem to do. Estimation helps us confirm that the answer makes sense. Now, if we have time in this lesson, we'll come back and perhaps do another problem, but if not, there are plenty of problems in the workbook. But now, let's go ahead and talk about an introduction to division. What is division? Well, some people would say, well, if multiplication is repeated addition, that division is repeated subtraction. And that's okay. But I would hate to do a division problem by subtracting many, many times until I got down to 0. So, another way of looking at division is that it's the opposite of multiplication. If we look at this next visual, we see that 6 plus 7 equals 13. And knowing that tells us that 13 minus 6 is 7. Knowing addition helps us understand subtraction. So also it shows us that if we know that 6 times 7 is 42, we know that 42 divided by 6 is 7. So just as subtraction is the opposite of subtraction is the opposite of addition, division is the opposite of multiplication. And that's very important because just as we looked at subtraction, we said the rules for subtraction are the same as the rules for addition. When we look at division, whether we're dividing whole numbers, decimals, whatever, the rules for division will use the same rules as the rules for multiplication. And remember, the multiplication rule was multiply digit times digit, place value times place value. Okay. Now, let us take a look at the next visual. It shows us 55 divided by 5. What is the answer? Now, you may know the answer, but I want to know the answer from a basis of understanding. The question is, what times 5 is 55? And as long as we're talking about how division and multiplication use the same rules, notice that 5 is 5 ones. The 55 is obviously 55 ones. Certainly isn't 55 tens. So the question is, 5 times what number is 55? And ones times what place value is ones? Well, 1 times 1 is 1. So the answer is going to be a whole number, obviously. And 5 times 11 is 55. That is 5 ones times 11 ones equals 55 ones. So the answer is 11. And my use of the notion of ones times ones may be a little disconcerting at this point, a little confusing. But that's okay because later on we talk about the long division algorithm, the long division method in lesson 3. I think you'll see that it really makes a whole lot of sense. And a lot of times where people get confused in long division, it's because they don't relate it to multiplication. So, but the problem is not all division problems work out. Not all division problems have nice, simple answers. I mean, yes, 42 divided by 6 is 7, and 55 divided by 5 is 11. But how about, as shown in the next visual, 38 divided by 6? What is 38 divided by 6? Well, again, let's assume we don't know the answer, and we're concerned about looking at it as a multiplication problem. What times 6 is 38? Well, if you know your 6 times tables or your 6 facts, you know that there is no number. 38 is not a multiple of 6. But we do know that 6 times 6 is 36, and the next visual shows that. It also shows that 6 times 7 is 42. So 38 is right there between 36 and 42. And if we multiplied 6 times 6, we got 36. What's left over? Well, there'll be 2 left over because 36 plus 2 is 38. The next visual shows that 6 times 6 plus 2, 36 plus 2 equals 38. And therefore, we could say, and do say, that 38 divided by 6 is equal to 6 with a remainder of 2. The visual shows 6R2. The R is, again, a symbol for remainder. So, and again, that simply means that 6 times 6 is 36. The remainder of 2 is added, which gives us 38. Okay, now, so division, and we'll get into the long division, like I say, in lesson number 3. Division and multiplication are very much the same. They're both not counting. We're not concerned about lining up place values as much as in multiplication, digit times digit, and place value times place value. So, at this point in time, let's consider a couple of problems. Let's go back to the whiteboard and consider a few problems, both in multiplication and very simple division. Okay. Go ahead and erase the previous problem. And let's try a problem that has a 0 in it. Sometimes that messes people up in terms of multiplication. Let's do a 2-digit times a 3-digit multiplication problem. We set up the lattice. And if you're still having a problem making this, you'll notice after a while you'll get very good at drawing the lattice boxes. Okay, let's multiply 509 times 99. A lot of people have trouble remembering their 9 facts, so it's a good opportunity to ensure we can at least know some of them. Estimation, 500. Well, 99 is pretty close to 100. 500 times 100. Well, 5 times 1 is 5, and 4 zeros, that's 50,000. So our estimate would be close to 50,000. All right, at this point in time, why don't you stop the tape, work the problem, and come on back, and we'll take a look at the answer. Okay, let's see. 9 times 9, this time I'll do it from right to left, is 81. 9 times 0 is 0. I put that 0 in there to make sure I know I did that I'll just leave it blank. And 9 times 5 is 45. Now, if I'm really slick, what I recognize is that these two 9s are the same, so when I multiply, I'll get the same answer. If you want to check on yourself, you can go ahead and multiply again, but I'll just go ahead, knowing I did it correctly, put the 81 in, the 0, and the 45. At this point in time, I need to add 1, and you'll always only have one number here. 1 plus 8 is 9. 8 plus 5 is 13. Write down the 3 and carry the 1. 5 plus 4 is 9, and 1 is 10. 4 plus 1 is 5. So it looks like the answer is 50,391. Notice our estimate was 50,000. That's very close. I feel very secure that this answer is correct. And hopefully you did it correctly when you stopped the tape. All right, let's take a look at a division problem. In fact, we take a look at a couple of division problems. How about 58 divided by 7? 58 divided by 7. Now, even if you know the answer without having to think, what I'd like you to do is think about the multiplication problem, just like we did the problem before, and then come up with an answer. So go ahead and stop the tape, thinking about a multiplication problem, and then a remainder, get an answer, and come on back and we'll take a look at your answer. 58 is not in the 7 times table. I do know that 7 times 8 is 56. And as Goldilocks would say, that was too small. And 7 times 9 is 63, which of course is too large. So someplace between 56 and 63, we have our number 58. Obviously, 7 times 8, 56, and we have to add 2 more to get to 58. 7 times 8 plus 2. So thus the answer to our problem, 58 divided by 7, would be 8 with a remainder of 2. Since 7 times 8, 56, plus 2 is 58. Again, it's very important to understand the basic foundation of division until we get to the long division method because if you don't understand what division is about, that method will make no sense. Let's try another problem. How about, let's see, 803 divided by 10? And again, it may seem a little more complex. It really isn't. I want you to stop the tape. Again, using multiplication, since division is the opposite of multiplication. I want you to work this problem and then turn the tape back on when you're done. Okay, let's see. 10 times what? Well, we know that all numbers that are obtained by multiplying by 10 end in a 0. So let's try 800. 800 is going to be 10 times 80. Since we know that when we multiply by 10, we just stick a 0 on the end. So 10 times 8 is 80. Now, how about 10 times 81? Well, that's going to be 810. 803 is between 800 and 810. So our answer, obviously, is going to be 80 times 10 plus some remainder. Well, what do I have to add to 800 to get to 803? I have to add 3. So our answer is that 803 divided by 10 is 80 with a remainder of 3. I hope you got that one correct. Let's take some time now to review what we've learned in this lesson, lesson number 2. The first thing we learned is that multiplication is repeated addition. I'm going to spend some time talking about this again because I really think it's important. Because the rules of mathematics sometimes seem like they came down from some mountaintop. That some person went up there and came down, they were chiseled in stone. And the rules really are quite simple if you understand the consistencies, as we talked about in lesson 1. Multiplication is repeated addition. It is not counting. We do not have to line up place values. In fact, we multiply each digit in our number by each digit in the second number. And in fact, the thing we must remember about multiplication is that whenever we multiply the digit times the digit and the place value times the place value. That's very important because later on, when we get to, for example, fractions, once we know where the place value is and where the digit is, then it's simply a matter of multiplying digit times digit and place value times place value. That knowledge alone will make how we multiply fractions understandable. Okay? Without it, it becomes a magic trick, some method, again, that the teacher showed you how to do and you had to memorize. I don't believe in that. I believe you need to understand what you're doing. So digit times digit, place value times place value. Also, I want to re-emphasize the importance of estimation. When you finish and you have an answer, whether you use old-fashioned multiplication, use lattice multiplication, which I think is very, very good, use a calculator. And again, we'll talk at length about the calculator in lesson 11. You need to estimate to make sure that your answer makes sense, that your answer is reasonable. Okay. Now, division. We've just introduced the notion of division, but we had to look at it as the opposite of multiplication. If we know how to multiply, then we can know how to divide. And in fact, at this point in time, when we're doing a division problem, all we're looking for is what's the closest number in that multiplication table. And then what do we have to add to get to the number in question? For example, another example, if we're dividing by 9 and we want to know what 70 divided by 9 is, we know that 9 times 7 is 63. 9 times 8 is 72. That's too big. So what do we say? We say 9 times 7, 63. And what must I add to 63 to get to 70? I must add 7. So that 70 divided by 9 is 7 with a remainder of 7. If you believe in lucky numbers, that should be a lucky division problem. Again, in our next lesson, lesson 3, we'll introduce and show you an application that shows why it works, the long division algorithm. I'll look forward to seeing you in Lesson 3.